Hydro Excavation. Safe dig. This presentation will address hydro excavation, the equipment, combination machine versus a dedicated excavating machine, best practices, safety, maintaining your equipment, and other uses. What is hydro excavation? It is the use of high-pressure water to cut the ground into pieces and remove via air conveyance into a debris tank, providing a non-destructive means to safely locate utilities and precisely excavate an area. This method represents a surgical excavation process as compared to a mechanical means. Hydro excavation benefits: safety. Eliminate the personal injury and death from hits, strikes of utility lines. Like water lines, gas lines, avoid the tremendous financial liabilities of damage to lines. Minimize the landscaping repair costs from excavation damage. The ability to excavate in a remote location where mechanical means cannot reach. Industrial applications: oil and gas refineries and suppliers. Utilities, like telecommunication, cable, power, gas, water, sewer departments, landscaping contractors, excavation contractors, and engineering firms. Various types of underground lines uncovered by hydro excavation. Multiple live distribution lines exposed without the risk of damage to property or people. Hydro excavation applications: waterline repair, exposing line, sewer pipe repair, subsurface engineering, water valve replacement, power pole hole, valve standpipe repair, hard digging conditions, gas line tie-ins, precision digging, digging with minimal landscape disturbance, digging around fiber optics, working in confined space, reuse excavated dirt. The equipment: no matter what size or make, they all use air conveyance systems. Air movement is created by centrifugal fans or positive displacement blower. Fans and blowers must be protected from the abrasives of the material being drawn into the machine. Moving material dry can cause excessive wear on air passages and fans. The use of water adds weight and lubrication to the material. Adding the proper amount of water controls the dust particle carryover and adds weight to the material for better dropout of the airstream when in the debris body. Centrifugal fans. Air inlet from the body. Air outlet. Dust carryover is controlled by water and fan speed. Two-stage fan. Air is drawn from the debris body into the center of the first fan. The air velocity increases and exits out the outer end of the fan. The air goes around a deflector plate and into the center of the second fan, increasing the velocity more, and finally exiting out the stack. Positive displacement blowers. A blower will create a lower volume of airflow than a fan, but a higher vacuum strength. Inside a blower are two lobe shafts that look like a figure 8 from the end. A blower is sized by the distance from center to center of each shaft and the length of the shaft. The clearance of the two shafts are 6/1000ths of an inch and do not contact one another. As the blower turns, the air enters one side. The lobes grab air and takes it around to the opposite side where it exits. Because of the close tolerance of the two shafts and the housing they sit in, little air can slip between or around the ends of the lobes. The faster the blower turns, the more air will move. In this view, you can see how much temperature increases on the outlet side. But imagine these little colored dots were abrasive dust going through the blower. I feel that if nothing but clean air goes through a blower, it should last forever. Airflow through the machine. Air and dirt flow up the debris hose to the body. Entering the body, airspeed slows down and the dirt falls to the floor. Air exits body through screens to stoplight items, then goes to the fan or blower. Positive displacement blower filtration. Air inlet from body. Cyclone. Cyclone cleanout. Microstrainer and filter. Cooling tower. Silencer. Air outlet. Airflow is pulled from the body, then enters the cyclone that creates a cyclonic rotation. Any debris is thrown to the outer interior of the cyclone and drops to the cleanout. Clean air goes out the top of the cyclone, then to the filter that stops anything still in the airflow. After the filter, the air goes through the blower and out the outlet of the silencer. Vacuum measurements. Mercury versus water column. 1 inch of mercury equals 13.59 inches of water column. So if a fan lifts a column of water 120 inches, or 10 feet, that would equal 8.8 inches of mercury. Most blowers will pull 15 to 18 inches of mercury. So if we put a vacuum hose underwater, 15 inches of mercury will lift a column of water 203.85 inches or 16.9 feet. Air conveyance. For either system to pull material further, we need to induce air to convey the material greater distances. Airflow. A fan will move around 20,000 cubic foot a minute. A blower will move around 3,200 cubic foot a minute. Fan versus blower. Fans move air in higher volumes and speed. Fans move dirt faster away from work site. Fans keep boom above the material, preventing accidental contact between boom and buried pipes in ground. Fans need less water to move regular dirt much faster. Fans are more productive machines for most hydro excavation applications. Fans are less expensive. Blowers pull slurry-type materials over long distances. Ideal for oiled field recovery work or mixed applications. Blowers can be submerged to vacuum material. Blowers need higher water usage for effective vacuuming. Blowers can be more effective to excavate in heavier, denser soils such as clay. Blowers are effective in all hydro excavation applications, but are not as productive as a fan machine. Blowers are more expensive. Combo machines versus dedicated excavation machines. Differences of a standard combo unit from what a hydro excavator has. High pressure, 2,000-2,500 psi, and high volume, 60 to 80 gallons a minute water systems, with a handgun circuit that is low pressure, 700 psi, and low volume, 10 gallons a minute. A hydro excavator has high pressure, 2,500 psi, and low volume, 10 gallon a minute water system, with a handgun circuit that is high pressure, 2,500 psi, and low volume, 10 gallons a minute. The hydro excavator gives you a high pressure to cut the dirt, but low volume, so you're not washing away the dirt and conserve water. A combo unit has fan or positive displacement blower with no additional filtration. Damage to a fan or a blower is more likely. Hydro excavator has cyclones and filters to protect the fan or blower. Can a combo unit be modified to work as a hydro excavator? Yes, a high-pressure hose and a wand can be installed. An additional relief valve may have to be installed to protect the water pump. Training of the personnel on how to hydro excavate and what needs to be done to protect the vacuum system. Thank you for your attendance.